Hey, it's Brian Vince from XPERIX. Want to get started with our webinar today for digital transformation for engineering. Along with me is Kevin Hill.
Hello.
And we are excited to bring you this webinar. So as most people know, we're in an area of digital disruption where companies really need to become a digital enterprise. And it's a lot different than just thinking about how you digitize your existing processes so that they're moved from maybe paper-based processes onto the computer. But it's really about rethinking every element of your business, of how you work with your customers, and how do you ultimately deliver value. So we're going to discuss some methods that we see that customers can really use to start to think about the way that they can transform their business, specifically around engineering. To do that, we want to start with a game. And as most people know, games are a great way to build up a knowledge set around something. The more experience you have with it, the better that you get with the game. You can typically, build out more strategies. What we're going to talk about first is around a game called Go. It's an old Chinese game, and most people in the US kind of know about chess. And so that you can understand the complexity between chess and Go, we put this in place. So if you look at this, the number of first moves in a chess match is really around 20 moves that you could make. So you have 20 possible options that you could do for chess. For the game of Go, there's actually 361 different moves that you could make. So it's a much higher level of complexity that is in the game Go. And there's been some companies that have worked to build AI tools to actually learn the game and try to master the game. So they've been doing this over the past few years. There's been multiple iterations. One of the latest ones was AlphaGo. And what you're going to see here is how quickly AlphaGo went from not knowing anything about the game, really from a strategy standpoint, just the basic rules and inputs, kind of like we might have some basic understanding of a product, to actually mastering the game. So if you look at this, within 3 hours of learning the game after just the basic rules, it was already at a beginner level. Within 19 hours of playing the game, it already understood some strategies around life and death. By 70 hours, it was already at an expert level, moving more to a superhuman level. So it's pretty amazing that within 70 hours that this computer could go from not knowing about the game to really becoming a master. So if we look at this, again, at 0 days, AlphaGo Zero had no prior knowledge, just basic rules. Within a matter of 3 days, they were now at a level where they were able to surpass AlphaGo Lee, which was a previous AI tool around the Go game that beat a world champion 3 out of 4 times. And in 21 days, it had reached a master level, beating 60 top professionals and the world champion 3 out of 3 games. Within 40 days, there was no other gamer on a human level or on a level of the other AlphaGo AI tools that could actually beat the AlphaGo Zero. So why is this important? Well, it's important for a couple of reasons. One, it wasn't just that we threw more people at it or we threw more horsepower at it. From the previous iterations, the AlphaGo Zero is actually using less power consumption and less compute power than the previous iterations that actually used. So they're doing this actually with less compute power and more intelligence built into the overall system. Now, why is that important from an engineering standpoint? If we look at how engineers really work and how we go about solving problems, engineering problems today, we typically use people and we hire people to go and figure things out. And they use their empirical knowledge, the experience of the team, to then go and define and make decisions around the key parameters that consequently determine what the product performance is. As they go through this process, normally the iterations are limited in size, they're typically sequential, And this is mostly a manual effort that you go through. So the question is, from an engineering standpoint, if we just continue to do that, how fast are we really going to iterate? Versus looking at new ways of doing things like the AlphaGo Zero did, what if your competitor worked in the same mindset of the AlphaGo Zero? How quickly could they actually get to the same level as what your engineers are? And how quickly could they actually surpass them? And what would that mean to your business? So how do you create your own AlphaGo Zero? Well, one of the things that we see is the use of simulation is continuing to grow and will become an important aspect of driving the future of product development. If you look at simulation today, most companies are really working in this area. They use simulation to validate, to troubleshoot, in some cases predict the product performance. But they're not really using simulation to explore, to go and automate the process of engineering and to explore what else is possible. But there are companies that are working in this space, much like the AlphaGo Zero, where they're using these tools from a compute standpoint to go out and explore and find new options. We kind of think of this as like trying to go climb a mountain. If you had an unknown territory, which is really your design space, or an unknown territory of a new mountain, how do you get there? You're facing all kinds of challenges. What walking path to take? Is it icy? Is it rocky? Do we have loose gravel? Do we have a crevice that we have to pass? Are there steep cliffs that maybe we need to face? And what do you do to actually get there? You bring a whole set of tools and equipment with you, and you try to use those to overcome all of these challenges. But a better option is really to think of hiring a Sherpa, because the Sherpa knows the way up the mountain already. It knows what you need and the tools to bring and the strategies that are most effective to actually climb the mountain and get to the top. And that's the modern approach that we leverage with some of these new technologies and tools. This framework allows you to look across the entire design space. It tunes itself to the design space as it goes through it and learns from the previous iterations. And it's very effective at solving complex problems. And most of the engineering problems that we face today continue to increase in complexity. So again, what you need in this area is not to operate at this level, but really to use the Sherpa to go out and explore and automate. And the latest digital engineering tools, you leverage the Sherpa to go and explore the design space and find new design.
Thanks, Brian. So as you saw how we could explore design space with current technologies today, so now let's look at what you're currently building, how you're currently engineering your product today. The question is, what happens if 20% of your team was no-show? What would you do? Could you survive on one less person showing up at your business every single day? And in actuality, you're already doing that. McKinsey's study found that employees are spending about 1.8 hours a day, almost a little over 9 hours a week on average, searching, gathering information, tracking down a document, looking for somebody to sign off information. That's all non-value-added work. So really, you're already losing one employee. But going forward, we all know that everybody's trying to do more with less. You're already doing less with less because people are looking at non-value stuff. So if you take a look at your business, what happens if one person doesn't show up the rest of the way? How are you guys able to work and continue to put product out the door? We think of this from a first, engineering strategy, the very first basic concept. Just organize your data to improve collaboration, to improve that management of information. So we're talking about a part or assembly and all the different information that is contained within your product that either currently today are on network drives or on file folder systems or different shared directories or websites and locations where people can go and access information, but it's all over the place. When you look at a component or a part or assembly, there's multiple different documents, from quality documents, manufacturing information of how it's actually built, customer requirements, or internal, regulations and government regulatory standards that you have to build a product to. Engineering changes. What is actually the true cost of a change going forward in the system? And actually your product design, the CAD files in and of itself, or electrical PCB boards or wiring harnesses or software that you have to manage, and all the simulation goes along with it. What happens? What if you could just leverage and manage all that in a single system under a particular given product? All that information is all these different systems can be now tied together in a single object, and all that information could be displayed and visualized across your enterprise moving forward in a PDM or PLM system that manages and tracks all that information, so everybody can see what actually is going on with the given product or process or manufacturing plant. Secondly, if you look at the dichotomy of the workforce, Department of Labor Relations says about 25% of the engineering workforce is over 55 years old. We also see about 25% of the millennials see themselves in a new job within the next year. Those are two very big ends of the spectrum of your given workforce. Back, the day, my parents, everybody, from my parents' perspective, everybody stayed at the jobs for 25, 30, 40 years going forward. So all that knowledge capture that they've had in that job, doing what they've done the last years, as they start getting to retirement age or are already starting to retire, what happens to all that knowledge that is walking out the door? How are you able to capture what they're going to do, tell the new hires that you're bringing in of what's actually going to go on in the product or in the manufacturing plant? At the same time, millennials are coming in with new ways of doing work, working in apps, electronics, automating workflows. So how can you capture the information that they come into a business within 2 years, do some really cool process improvement, and they're out to their next job? How are you capturing that also, their new knowledge moving forward as another new person comes into your facility as well? So we see the second strategy moving forward is truly capturing all that knowledge that is either coming in and also walking out your door, and be able to reuse that for the next new employee or for the next new product that you want to start moving forward with, as Brian talked about in the beginning within the design exploration space. The first thing is just looking at it from a template perspective, creating these design templates. Most of the companies that we're working with have the same product. There's different tweaks, different configurations that they're doing to the product to still put it out the door. What happens if you could templatize most of the parameters around a given product and just varying the different variables that go in there, and the design actually grows or contracts or adds or subtracts based on that templated approach? Customers are seeing about 80% productive gains by leveraging these templates moving forward for different aspects of their business. And this is codeless configuration of building these templates within your design CAD software that you could leverage going forward from there. The other thing, as you go through your design reviews or your engineers are cutting sections and doing measurements, why don't we start automating all these clearance checks, all these boundary conditions to make sure we're not touching, service area space, collision detections. As we go through all this stuff, let the tools do this for you instead of having your engineers spending hours running through cutting sections to making sure everything can be built and we're not going to have collisions as we eventually take a design and actually manufacture it. And that leads into the upper right picture of capturing data or capturing errors early in the process. We're saving much more money downstream. If I capture the same error in the plant versus I capture it as I'm still, before I even cut a single tool, those $1 million errors become $100 errors. By putting in the correct quality checks within our designs or within our documents, be able to capture that stuff way ahead of time. So before tools are cut, before manufacturing starts producing, we can make sure that that design is actually manufacturing feasible, not just, hey, this is engineering ready and we're ready to go. Also, there's definitely tools out there that, from a milling perspective, I could actually, plan for manufacturability, different routes that our tools can take up to 60% faster for rough milling. Also in the lower right, we're looking at all the different dimensional data that's going to be put on a drawing from a 3D perspective. Different people or different departments need different pieces of information. So why don't you enter it once and let everybody reuse often of what they actually need to go forward from there, from doing your your PPAPs to what manufacturer needs to cut a tool or how they have to shave off a surface after it's rough cut and things like that. I'm actually ability to keep reusing that information instead of producing multiple drawings over and over again, or different drawings of the same thing for a different department. Again, those are two just simple ways that we feel that us as a company could partner with companies like you guys to go forward and truly be your digital Sherpa to help you go to that next level of your product and that next level of innovation to keep you guys in business for the next 10 to 15 to 50 years. So, between Brian and I, we have over 40 years experience, and we became disruptors ourselves and left corporate America to start our own company. And we're bringing those, world-class tools to help companies like you thrive in this digital disruption area. We feel that with the set of tools that are out there in the marketplace, there's a big way that we can help you guys innovate moving forward. So when we look at our company XPERIX, there's really four main tenets of what our company is all about. Today we've been talking to you about digital transformation, digital engineering strategies. We could actually work with your leadership team to help you guys plan out what your transformational journey is all about, what it can do for you, how you guys can innovate, and go from there. Secondly, we also look at our engineering services. We actually do true engineering consulting work as well. And everybody's trying to do more with less. We also handle all the outsourcing. We could augment your staff to handle all the engineering systems or to help train up your internal employees moving forward from there. Third, we also do engineering services and different innovation projects. Like Brian talked about in the beginning on the design space exploration, we could leverage, to do a reverse engineering project of a given product and go from there and let you guys see the results of that and see how you could actually truly innovate your product as you guys are continuing to build and do work that you have to do today to put product out the door. And finally, we are a Siemens reseller as well. So throughout the engineering services projects or through our consulting on transformation journeys for your companies, we could recommend different solutions as well. And it'd be as by being a Siemens reseller, we could sell you that software as well. Again, this is kind of a different breakdown of our four tenants, but kind of goes in a little bit more detail of our services. From a digital transformation perspective, we truly feel that with the current tools today, a lot of companies aren't leveraging what's out there in the market. We feel that we could bring 10 up to 50% product performance improvement to a given product just by coming in and talking to you guys and looking about what you guys are doing today and what certain tools can do to help you get that improvement. Of course, we can talk to you about, help support all around Industry 4.0. We can help within your benchmarking for, PLM, CAE, multiple different new solutions. Help again with that transformational journey within your company. Also, PLM and software management services, rapid deployment of PLM and ALM. We haven't really talked about ALM in this webinar. I believe we'll be hosting one in the near future, but this is truly all around software management, managing all your code that you put on sensors that goes into product. And finally, also the simulation services. Again, the engineering projects that we've talked about or the innovation projects. Again, products redesigned for additive manufacturing, all CE simulation, some of the design exploration space that we've already talked to you about. Again, thank you guys. This is XPERIX. We would love to partner with you guys. We look forward to talking with you how we can help you guys innovate in the future.